So let's try bring everyone back in the panel discussion. I don't know whether Takashi is also around, if he can join. Oh, yeah. So Takashi, yeah, all right. So we have everyone here back. Oh, is Stuyan as well around? Okay, if you have any questions or comments and discussion topics, just please put it in the Discord channel and then we can pick it up. So I think there's lots of diverse topic in this session, and I think this is really helpful for really discussing a big picture of embodied intelligence, and also in the context of artificial life, I suppose. And probably the good place to start the question is coming back to Takashi's statement about the Brooks juice, right? Do we know what Brooks juice is? And Takashi has some idea how it might look like. We are looking at it in a material level or computational level, or small scale, large scale. I think this is a kind of common denominator of our interest. So maybe I just ask Takashi first what you think about all this diverse research topic at this moment, because you started with oil droplet, and now you're talking about the imitation process and so on. Do you think you can just give us a bit of your views on how we could discuss Brooks juice from all these diverse topics?
Yeah, I was expecting this difficult question from you, actually. I'm not quite sure what is the best way to answer to it, but my idea is that mind is different if the body is different. So if you have a body A, but you cannot install mind A to the body B, right? If you install mind A to body B, and the mind becomes mind B, right? So, but any micro scales or a large scale, there should be some sort of a different types of mind exist. So I was wondering, what is the minimal scale or minimal gradients that we can take as a mind, right? For example, like my droplet fails to have, it's almost there, but I couldn't get that drop to say that droplet has mind, but they have the very much like protochemical reactions, and they try to escape from the pH gradient, and then they also interacting nicely with the droplet. I think if the material has at least kinds of mind, kinds of memory, then that's the first step. So I was listening to what the people are saying. I don't think those materials has any good memory. They seems like an instant reaction to the environmental stimuli. So I was just wondering how you can have a long-term memories and using those memories to do something. And that's something that I think it is necessary. For the case of oil droplet, there's a bunch of vortices is formulated in oil droplet. Sometimes it's 6, sometimes it's 4. And that determines the temporal scales of how the reaction time scale of the droplet is to the environment. So I just want to know how you can understand memories, but also the prediction is possible in a very simple materials. Not only memory, but also the prediction. The simple types of prediction is possible with a minimal material. So I just want to know those opinions from the people actually working with those micro structures and micro robots.
Okay, Jonathan.
Yes, please.
Yeah, I think that's a really good point. Many of these materials do seem to be instantly reacting, right? And then that seems very primitive. But if you put 2 of them together that have that instant reaction, you have a trade-off, and memory is relatively achievable in those kind of circumstances. But I would also say that materials and structure become an important part of this, right? So I know we're living in the real world, so we are living in the physical, mechanical domain. And lots of the discussions we have here are about, and Nagai-sensei talking about the cognitive end, but it's important always to bring in the kind of physical domain too. So I think you're right. Materials, I think it's doable. Memory is absolutely important to get control systems, automata, the kind of conventional computation that we're interested in. But also we have that ability to do things in the mechanical domain, which is obviously where Barbara works a lot with the plants, and lots of us work in that kind of area. We can't get away with it.
But do you think this material can use that memory? The memory that we can observe, there is a memory in this material, right? But the question is whether this material itself can use those memory to do something, to change its function. That's something that I think we needed, right? So we call it internal state, which is sometimes decoupled from the environment, sometimes must strongly coupled with the environment. But this coupling mechanism is very important once you try to think about the cognitive capability of this material. Yes, please.
So I think Ikigami, it's a good point. I think there's a lot of challenges like that for different functions, and memory is a good one to try to say, well, in order to have something, you know, intelligent, it's nice to have memory, it's nice to have movement, it's nice to have energy storage, a lot of these things, and we are trying to incorporate a lot of these things. I think it is really possible to have movement actually affected by memory. In fact, this is something that on a large scale, Jonathan Ruster had actually done with some Nafion materials. And this is something that we expanded on later, where we could actually program Nafion materials to behave differently at different temperatures. So using both a combination of shape memory and actuation, you can have different types of actuation at different temperatures. And so you could program the ability of something like this. So it's a type of memory. You can have different states.
I totally agree with you. But do you think it's different from the growth ring of trees? Like growth ring of trees, they memorize, you know, this year was very cold, this year was very hot summer. So that can be reflected in this growth ring of the tree, so that seems like we can program it by changing the temperature, but the tree itself cannot use those memory to do something else. So that's my question.
Sure. So what I wanted to say is that while this is an initial, like, weaker demonstration, one of the things we're trying to do now is we're trying to couple reactions with the way some of these structures form. So when you have reactions, you may be able to dynamically change write and rewrite memories, is what I'm trying to say. And so when you have reversible actions that could affect the polymer structure that you're doing, then I think you may be able to achieve something close to the kind of memories that you're talking about. And again, I think it's wonderful, the kind of like vision that you had with that droplet, because, you know, you're thinking what could happen with it. And I'm hoping that with some of the things that we're showing, we can map out some of the things that where we can go with different directions. I mean, eventually, the hope is that you can actually have so many functions that we can approach what we think is now artificial life. Even for life, there's no perfect definitions, but basically people finding a lot of the functions put together. One of the things that will be wonderful is having not only grow some of these structures, but be able to have them replicate, because for manufacturing, that will be excellent. So both decomposable structures, but ones that can persist. So no environmental effects, but still being able to have long-term persistence.
Barbara, do you want to go ahead next?
Yes, I really like this discussion memory, because I think that all the organisms, living organisms, change the behavior on the basis of the memory that they have. Also plants, you are right, Takashi, not only in the ring, but also they have a memory of the experience. It seems that I mentioned climbing plant, they touch the support, and then on the basis of the analysis of this feedback, they decide also on the previous experience if this is the right support to start to grow, to attach and then to start to grow. So the memory is mainly, in that case, in the material, not of course in the brain. As I said, this is why it's also a very interesting model because we can compare different solutions in nature in systems that have also a neural system and other that they don't have, but still they have the same mechanism. So memory, it's also relevant in other organisms that don't have at all neurons like a brain, but they have another solution more at the material levels. So the analysis is local, and then they exchange the information with the other part of the plant. So there is an internal communication that is also fundamental in the behavior. But I really think that we should consider more and more memory in our robot and our technology, because they are fundamental for the behavior, as all of you say.
Yuki, yeah, go ahead.
I also really like the discussion about the memory, the bodily memory, from also the viewpoint of the developmental robotics. We don't have there like a robot which can physically like growing up, but the robot, their bodies can store what they experienced. And also in case of the humans, once we use their motors or their sensors, their sensory, the low level, they adapt in the long-term manners. And this really determine the precision of the sensory signal in the motor systems. And I think that such a motor, their sensory motor experiences at the lower level can store their own memories in terms of their precision and also the tendencies of their behaviors. So I hope that there's such a memory, the ideas in their body embodiment can also nicely contribute to the studies of the developmental robotics.
Okay. Dario, do you want to add anything from morphological computation point of view, or your adaptive morphing robot?
Well, maybe the discussion went more on the material side, which I didn't cover in my presentation today, but just want to make a comment here. I hear a lot of language where we have the brain and when we have the matter. And as a matter of fact, and which is what, of course, I had in my talk today, but as a matter of fact, maybe this distinction, we should not even use it anymore. And I think we've seen some of the presenters today showing materials that have a lot of intelligent properties without necessarily having brains. So I'm not sure whether this is what you call the missing juice, Takashi, or whether, because there are multiple levels at which we can look at this. But today, over the past at least 10 years, the progress in soft robotics and bringing together the community of material scientists, and people like Stoyan, for example, and allows us to do things and to understand things in a way that we would not be able to do 10 years ago when embodied intelligence was discussing this. So maybe it's something we should think more about it, and also like teaching graduate students to think more out of this box, not only just to control the brain and the material.
Yeah, absolutely. Takashi, you want to go ahead? Yeah.
Yeah, actually, the other thing what I'm doing right now is what I call entire tracking. Like Honeybee Hive has 1,000 individuals, and then we tracked all these individuals. We working with the people from University of Illinois. That each bee has a QR code, so that we can trace everything, and then using massive machine power to see which one is doing what, right? So this individuality and then the property of a macro collective is sometimes is corresponding, sometimes not, and then some differentiation occurs, and that determines very interesting functionality of as a swarm, right? So don't take any a simple approximation of swarms and things, but we really have to tracing all the individuals, and then maybe we can open up some new kind of science, right? New kind of scientific paradigm that we don't have to make a mini field approximation or something, but without losing complexity of the collective, but still we can make a science on top of it. That's my answer to Dario, that I want to teach to the next generation, that maybe there's some new ways of thinking. We don't make any storytelling or narratives, but maybe without making a storytelling, but still we can understand what happens in these material ensembles and swarms. So that's something that I'm looking at, using like a tetrahymena or honeybees or ants or many other like millions of birds, flying out in the computer. That's another thing that I'm working on. So this the new kind of complexity is in front of us right now, and that's in that sense I agree with you, Dario, that it's something different right now. Yes.
Yeah, if I may just add one thing. So as some of you know, a lot of my work has been in the field of evolutionary robotics, and we still have some in the lab, which I didn't cover today, because I want to make that single small message. But I was wondering whether we shouldn't look at everything in the perspective of evolutionary systems. So because at the end of the day, we observe a lot of interesting phenomena if we have these active materials, and then we assemble them in metamaterials. But at the end, in nature, something makes sense only if it can reproduce itself. So it becomes a unit of reproduction. So the swarms that you were mentioning, Takashi, they are maybe not superorganisms, but they become a unit of reproduction whereby they compete with other swarms that is in their environment. So I was wondering whether we should reconsider, of course we cannot reproduce materials yet, but I was wondering whether we could reconsider the juice would be some material or some elements that can come together and become a sort of unit of reproduction to some extent, or interaction with other similar macro units. I'm not sure if I was clear, but a bit of brainstorming.
Well, that's a very interesting idea. Well, actually, like Penrose, I mean, that's not the Nobel laureate, but his father found very interesting, a combination of the block, and once they have a specificity with the block unit, then the replication starts to happen, right? So maybe some kind of specificity of the morphological specificity coupling with the other thing, then the replication starts to happen. So maybe you're right. Some very key morphological structure is a Brooks juice that we have to find out, and then from that we can see the emergence of intelligence on top of it. But for the moment, I'm not sure where we can find that, or whether we can design such materials when coupling with some other things and show totally different type of properties, and then from there that we can find something new kind of intelligence on top of it.
Okay. Yeah, Jonathan, go ahead quickly.
Yeah. No, yeah, only very quickly, because I think Takashi's right? We don't know whether we can do this, but I feel this is an area which this community needs, right? It needs to have that investigation into this, let's be outlandish about the materials. Let's be outlandish about the intelligence and the materials and the capabilities and the way in which we do it. And so, yeah, I'm totally agree with that. I think we should all agree to be as adventurous as possible. That's what we need to teach the next generation, right?
Okay.
Great summary, Jonathan, as usual. Thank you very much. Yeah, I think this is really interesting discussion, like we're connecting all this different kind of research, but we're actually looking at the very similar things after all. I'd like to thank you all for all the presenters and all these discussions, and we just need to move on to the next session. So please do continue discussion in the Discord. We're also encouraged to use this the voice interaction tools if you want to, and we can have a bit of a discussion over there as well. So yeah, thank you very much for all the speaker this morning, and I'd like to thank all of you on behalf of all the participants, 240 participants right now. So we'll continue discussing all these topics later today.